Okay, I wanted to go over these quizzes, and I am a little scummy because I already went for my walk today. And so anyway, this is what exercise looks like. So here we go. All right, sine, cosine, and tangent, their input, what you put into them is an angle, okay? And that could be in degrees or it can be in radians, but that's what they eat, and then they're going to spit out a ratio, okay? Where inverse functions are going to have an input of the ratio, they're going to spit out the angle, okay? Whether in degrees or radians, depends on. Now, you have to be careful with inverse functions. Remember, sine is on the side. So inverse sine, his buddy is what? Cosecant, inverse, and then tangent is with that, okay? And again, the input on all those is a ratio. The other ones are in the cap. So that would be inverse cosine. His buddy is what? Secant, inverse, and then cotangent is split from tangent. And so that's a problem. You always got to kind of remember that. All right. So let's look here. Inverse sine of a half. Okay, well, you're on the side. So you don't have all four quadrants. You only have these. It's positive, right? So you're right here. Square root of 3 over 2 and a half. And then I want, this eats the ratio, spits out the angle. I want pi over 6 or 30 degrees. Okay, here. Inverse sine is on the side, so I can't be here. I want negative square root of 3 over 2. So I'm going to go over a half, down square root of 3 over 2. This guy is going to spit out an angle. Okay, now I don't really care what that angle is, alpha, beta, I don't care. It doesn't even matter what it is, because then the next guy is going to eat that same angle, input angle, and spit out the ratio. Well, because I'm still in the defined area, it's going to spit out that exact same ratio. Okay, because I haven't moved. I didn't have to reflect. I didn't have to go anywhere. Okay, let's look at this one. Okay, tangent of 2 pi over 3. All right, so here's, pi over 6, 2 pi over 6, 3 pi, 4 pi over 6. So that's my 2 pi over 3. All right, now, if you have your tangent written down, that's great. But notice this guy is going to eat an angle and spit out a ratio. So it's going to spit out a ratio. And then the inverse tangent is going to eat that ratio and actually spit out an angle. So I need the angle. I don't even need the ratio. Like, I don't even care what the ratio is. All right, now, is inverse tangent defined here? No. Inverse tangent is on the side. And with tangent, you can always slide across. So I can slide 180 across, and I'm here. Now, all of these side ones have to be between negative 90 and 90. You can't even say like 110 degrees or anything like that. It has to be between negative 90 and 90, or in radians, negative pi over 2 and positive pi over 2. So I have to answer a negative pi over 3. Even though I know I'm here, I can't use the normal, unit circle positive angle there, because it has to be between negative 90 and positive 90. All right, here I highly recommend putting all your tangents on the unit circle, like square root of 3 over 3, all of those guys. Now, the nice thing is 1, right, is your 45s, because square root of 2 over 2 divided by itself, right, is going to give you a 1. All right, now, inverse cotangent is on the cap. So you don't even look at these guys, all right? So then you're like, okay, oh, it must be here, right? Because this is going to give me a tangent of 1, or tangent of x is going to be 1. And when I flip it, right, cotangent is also going to be 1. Okay, so where am I at? I'm at pi over 4, or 45 degrees. All right, how do you do these on your calculator? All right, so remember, this is eating a ratio. This is not on my calculator. So C goes with S. I'm going to use inverse sine. And remember, it's the ratio that flips with reciprocal functions. We never flip an angle. All right, so on my calculator, I'm going to make sure I'm on degrees. I am. So I'm going to do inverse sine of 1/3. And I get about 19.5 degrees. Okay. Now, the problem comes with this guy, because he is our problem, right? He's separated from tangent. So if you want, yeah, you can do inverse tangent. Again, it's the ratio that gets flipped with reciprocal functions. So I'm going to do this, but I know my calculator is going to give me the wrong answer, because unless it's in quadrant 1, are you guys okay? Quadrant 1 is defined for every inverse function. right? That's the only one. So if you're in quadrant 1, life is great. You're not in quadrant 1, not so much. And I have a negative here, so not so much is the case. Okay, so I'm going to go second tangent, and I'm going to get what, negative 1/6? I know this is the wrong answer. Okay, I'm at a negative about 9.5 degrees. Okay, so I'm here at a negative 9.5 degrees. All right, inverse cotangent is on the cap. This is an illegal area for it. I have to be on the cap. So the nice thing about tangent, sine and cosine, you either have to, reflect this way for sine or reflect this way for cosine. But tangent always slides across at 180. So I'm just going to add 180 degrees to that. And I'm going to line up straight across from it. So I'm going to add 180 because I'm sliding straight across. And I get, what, 170.5 about. Okay. All right. Next one. Okay. So this is giving you a ratio. Notice I'm not giving you any angle here. So I need to do a bow tie. Inverse sine, so I have secant, kind of got a little cut off here, but inverse sine of 3/5. And I didn't have to tell you what quadrant I'm in because inverse sine is on the side. So these guys are out and it's positive. So I know my bow tie is right there. Okay. SOHCAHTOA, opposite. So opposite from my angle is 3. Hypotenuse. This is a 3, 4, 5. So I just know that. If you're going to do Pythagorean theorem and you know the hypotenuse, then you know the 9 and you know the 25. This is going to be a subtract kind because anytime you know the hypotenuse, it's a subtract kind, and the square root of 16 is 4. All right, so this guy is going to eat the ratio, right? And it's going to spit out an angle. The secant's going to eat that angle. So my final thing is a ratio. Okay, what ratio? Well, secant is the flip of what? Cosine. So cosine is adjacent over hypotenuse. So I'm going to flip it and write this. And that's my final answer. Okay. All right. Let's look at the next page on this quiz. All right. This guy. Again, this is going to eat an angle, spit out a ratio. The inverse cosine is going to eat that ratio. So my final answer is an angle. I just have to decide if that angle is legal or not. All right. Well, let's look. Cosine negative pi over 8 is about right there. Okay. So that's going to spit out a ratio. And we're going to have what? An x and a y there. The x is going to be a positive ratio. The y is going to be a negative ratio. Now, what do I care about? I care about cosine. So I care about that positive ratio. All right, now I'm going to do inverse cosine, okay? So that has to be on the cap, but I'm not there, right? Like I'm not in the right location. And I care about my x value staying positive because I don't care about the y at all. I don't care about sine. So do you see how I'm going to have to fold this up? I'm going to have to reflect up. So this guy is going to reflect up, so it still has a positive ratio for the x. Now the y is positive too, but that's sine, and I don't care anything about it. So my answer is pi over 8. All right, let's look at this guy. All right. Period is always 2 pi for sine and cosine. For tangent, it's pi. Okay, the period's a little different. 2 pi divided by the coefficient of x. So that's 4. So you get pi over 2 because 2 goes in there twice. Okay, amplitude is the absolute value. We don't do negatives, so that's 3. Phase shift will come back. Vertical is a -2, so we're going down 2. The domain is all reals, or you could do negative infinity to infinity. The range, we might as well do that now. Normally it's -1 to 1, but you multiply by the amplitude, not the negative though. So I get what? -3 to 3. That's my stretch, okay? Then I do my vertical shift. This is all output, -2, -2. So I get -5, 1, okay? So that's going to be my, low and my high. All right. Overall shape, sine normally would look like an S, like that, but it has a negative in front, so it's going to be reflected. So it's going to go like that. So it is a reflected S. All right. Is it reflected? Yes. Okay, let's get the phase shift and do that. Okay, so let's deal with the angle. Here's your angle. Normally, you go from 0 to 2 pi. So you want to trap, oops, it helps if you write the right number. You want to trap your angle between 0 and 2 pi. Okay, then I'm going to add the pi to all of them. and then I'm going to divide by the 4. All right. So your phase shift, this is your new start. So it's going to the right, pi over 4, okay? All right, this is my start. This is my end. Now, some of you had issues graphing. You didn't have any tick marks on your x-axis. You just can't draw the shape. Like your units have to work. Now, notice if you go pi over 4, 2 pi over 4, 3 pi over 4, that's only 2 things. The sine curve always has, you know, between shapes, there's always 4 pieces between going like, you know, when you go from mid to high, then high to mid, and then mid to low. Those are 4 pieces always, 4. I only have 2. So it would be a real good idea to cut these all in half, which means I'm going to take half of the ends. I'm just going to get a common denominator, right? I'm going to call that 2, sorry, and 2. Okay, I want to get a common denominator. All right, so now I have what? 2 pi over 8. My x, because I don't want to divide this by 2, right? I want to actually just write equivalent fractions here. So 6 pi over 8. That gives me more tick marks now. Okay, so now if I have pi over 8, and then 2 pi over 8, 3 pi over 8, 4, I don't even know what I'm saying. Pi over 8, 2 pi over 8, 3 pi, 4 pi, 5 pi, 6 pi. I have enough to get all the things in that I want. All right, so if these are too close together, right? You multiply the top and bottom by 2, top and bottom by 2, numerator and denominator, so that you have more cuts, okay? All right, so let me see what I have here. All right, where are we at? Our low is what? -5. 1, 2, 3, 4, 5. So this is a -5. And again, you need consistent units. Can't just sketch it. And then 1 is here. Okay, this is your high, this is your low. Okay, your mid is your -2. So my mid is right there, and that's halfway between them. All right, now the first units I had, pi over 4 and 3 pi over 4, did not give me enough tick marks. So I doubled and doubled, doubled and doubled, just got a different common denominator. So now notice I'm in 8s. So I'm going to label this guy pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, and I'm just going to space them out. Again, on a graph, you have to have consistent units. Same thing over here, -pi over 8, -2 pi over 8, and then just consistent units. All right, let's go to our start and our end. Okay, and again, we know this is what? A reflected S. All right. So a sine starts with a mid. So let's start with a mid at 2 pi over 8. We're going to start with a mid. 2 pi over 8, I'm going to put a point at a mid. All right, it is going to end at 6 pi over 8 with a mid. So I'm going to go to 6 pi. So this is what? 5 pi over 8, 6 pi over 8, and I'm going to do a mid. Halfway in the middle is another mid. So let's go 1, 2 in, and 1, 2 in. There's another mid. See how now I have enough tick marks. Halfway between these, I have a low. So let's go down to a low. Halfway between these, I have a high. So every tick mark I change, okay, in this graph, sometimes you jump a couple tick marks, but every tick mark changes. So let's go back. So we're mid, high, mid, low, mid. So this guy's going to be a high. The next one's going to be a mid. The next tick mark's going to be a low, and then a mid, and then a high. And we're going to keep going. Okay, so I'm just going to kind of, and again, make these curvy, not pointy. They're not absolute values. Okay, and then you go. So again, you need your, not only this labeled accurately, but you need tick marks that are consistent. You can't go like pi over 8, then pi over 3, then pi over 7, no. Pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, or, you know, pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, stuff like that, okay? All right, and at most, you're going to have to multiply by 2 and 2 just to kind of cut them one time usually is enough, okay? All right, hopefully that helps. I will go over the other quiz as well.